In this video, we're going to start talking about logarithms and logarithmic functions. So a logarithm says for all real numbers y and all positive numbers b and a, where b is not equal to 1, y equals log base b of a if and only if a equals b to the y. So as I already said it here, this is read as y equals log base b of a. This is not b to the a exponent. Okay, so this is not an exponent here. B is the base, a is not an exponent. It's a subscript. So b is a subscript. So log base b written as a subscript of a. So notice here that b is the base, and over here we have it written exponentially, and b is the base. So that's a good connection between the two. These two are equivalent statements. Here on the left, this is what we call logarithmic form. And on the right, this is exponential form. The two are equivalent, okay? They mean it's different ways of writing the same thing. So log base b, base b. And notice here, y is the exponent. So log base b of a equals an exponent. Okay, so logs equal exponents. In fact, a log is the exponent to which a base number must be raised to produce a certain value. So essentially it's saying, what exponent do I need to put with this base to get this value? So logs equal exponents. I'm going to say that a lot. Our first task to get familiar with logs is to take a logarithmic statement and write it exponentially. So I always start with the base. We have base b, base in exponential form. So looking at log base 6 of 36 equals 2, I'm going to start with the base, log base 6. So when I write this exponentially, 6 is the base. Then I'm going to look for the y value. So logs, this whole log, equals an exponent. That's the exponent in our exponential form. So this whole log equals an exponent. So the exponent is 2. So 6 to the 2 power equals the only number I haven't used yet. So log base b of a. Our a is 36. And this makes sense, right? 6 squared is 36. So we can see how these two things are equivalent, and it makes a true statement. Start with the base. Logs equal exponents, so figure out what that log equals. And then in exponential form, that will equal a. So the only number you haven't used yet. Let's look at this next one. Log, what's the base? The base is 5. So when I write it exponentially, my base will be 5. Logs equal exponents. So this entire log equals the exponent. The exponent is -2. Equals, the only number I haven't used, 1 over 25. Again, this makes sense. The negative exponent takes the reciprocal, and 5 squared is 25. So this is the exponential form of that logarithmic statement. Try these two examples on the right-hand side. Alright, let's see how you did. So the first one, we're writing it in exponential form. Log, what's the base? The base is 2. So in my exponential form, the base will be 2. Logs equal exponents. So this whole log equals the exponent. The exponent is 1/2. And that will equal the only number we haven't used, which is the square root of 2. Again, this is a true statement. If I have a rational exponent, the denominator is the root. So this is the square root of 2 equals the square root of 2. Let's look at this last example. Start with the base. Log base 2. So again, the 2 is the base in our exponential form. Logs equal exponents. So this log equals 6. So the exponent is 6 equals, the only piece we haven't used, x. So that one, we have a variable in it, so it's not going to be like a true statement like these that we can just look at and verify. This would be something that you would be solving later on. So that's the key. The first is start with your base. Log base what? Then logs equal exponents. So what does that log equal? That's your exponent. And then this will equal the only value you haven't used, which is your a value.